Hi, this is Greg from Structure Toolkit, and in this video we're going to be going through Analysis Lite. Analysis Lite is a tool within Toolkit that gives you a 2D space in which you can draw up to 4 nodes and linearly analyse with complex load-in scenarios. All users with a current subscription have access to Analysis Lite. Analysis Lite by itself gives you a lot of features to work with and is often all you need. But if you require 3D or more than 4 nodes, then you'll want to look at our full standard analysis package. Details of this can be found on our website, along with information on the differences between Lite and standard. In this video, we'll cover the following using Analysis Lite: creating nodes and members, and also adding restraints, which will all form the basis of your model; creating member sections to apply to all of your members; creating loads to add to your model; analysing and viewing your results; and finally printing and exporting your results. Have a look at the timestamps on the screen if you want to skip to a section. You can either open up an analysis document from the document tab at the top, or under the blue analysis section on the desktop. On the desktop there are 3 options to choose from: New, which opens up a blank analysis document; Wizard, which is a standard analysis only feature that allows you to build various model types quickly using generic inputs; and finally Examples, which gives you examples of what can be created using analysis. To show how a model is made, we will start with a blank analysis document, and so we'll click New. For this example, I'll create a simple brace frame, and so I'll just call it that. The next thing we'll be asked are if we want to use some default load combinations. As we'll be using a combination of dead, live and win loads on our model, I'll pick the last one and go OK. Do note that you can make your own combinations yourself. It is just generally easier to use the defaults if they apply to you. We will then get a dialog that explains some general controls and shortcuts. We'll go through this ourselves, so I'll just close it. In the analysis window, we get 3 main areas. The center is the space in which we draw our model. To the left is an information and viewer pane. We'll see a bit more of this closely later. And to the top we have the analysis menu bar, which is where we'll access many of our analysis features and tools. The first thing we want to do on a new model is draw our nodes and members of our model. There are a few ways we can do this, and I'll try and show each way while drawing out our 4-node brace frame. The first way we can input our nodes and members is by using the drawing tool. This can be turned on by either pressing the spacebar or by pressing Ctrl D. Next, we could just click on the screen and start drawing if we wanted to. But to be more accurate, it's probably best to type in some coordinates ourselves. To do this with the drawing tool, we want to press the @ key. This will open a little window and ask me where I want to put a node. The first node I'll put will be at 0, 0, being the 0 coordinate of x and the 0 coordinate of y. As we only have access to 2D, the 3D coordinate for z doesn't really matter here. To add the node, we'll then click Enter. As you can see on the screen, we've got a little node 1. To then add another node, we'll press the @ key again. Notice this time the window has a little bit more information in it. What we're doing here now is entering in a new node with its coordinates relative to the previous node. In this case, I'll put our next node 3 meters above our original node, so I'll type in 0, 3. Another option we also have is a checkbox for generating a member from the last node to the new node. This is something we want, so I'll leave it on. At the moment, it's a bit hard to see what we've created. So to zoom into the extent of our model, I'll press Ctrl E and then zoom out a little. For the next node and member, I'll use a different method of entering the node. So for now, I'll turn off the drawing tool by pressing the spacebar. Another way of inserting a node and a member is by pressing the node button at the top. In here, we can insert our new node's location and click the plus button. In this case, as the relative checkbox is unticked, the new node I put in will be based on its coordinates only. So I want to put in a new node 3 meters across from our second node. I'll need to put 3 meters in both the X and Y. I'll keep generate member on again to allow a member to be created. Do note that if these checkboxes are grayed out, it's because there was no detected node to base these options off of. This could happen if you delete a node and go to input another one. To add the node, I'll now click plus. The final node we will create will be 3 meters below our third node. I'll untick the generate member in this case and show another way of creating a member after. Next, to add in the final node, we want to have it 3 meters below node 3. So in coordinate form, that should just be 3 in the X and 0 in the Y. And then we go add. As default, nodes will be named with an N and then numbered sequentially, as you can see with our frame at the moment. You can, however, rename nodes by selecting them in the drop-down and clicking rename. Or by giving them a name in the ID box when you go to create them. You can also edit the data of the nodes through this table button. To create a member without using the generate member between nodes option, you can click the member option at the top. In here we can pick the nodes we want at the end of our member, in this case node 3 and 4. To create this member we have to go create, click node 3 and then click node 4 for each of our ends. Like with the node interface, we also get a variety of advanced options you can pick from if needed, such as member end fixities, but for now we'll just stick with the standard member. To add it, we'll go add. Once we click add, we can see it appear on our model. The next thing we'll do is add our restraints. To add restraints to a node, click on the node in question. It will then be highlighted purple. Right click, go node selection, assign restraint, and in this case we'll do pinned. We can then do the same process on the other node and get pinned as well. With restraints added, the basis of our model is done, and we can now create and assign our member sections. To do this, we'll open up the section tab at the top. As a default, there is already a section with a 250 UB, which is what we can already see on our model. What we'll do here is edit this already existing section to what we want for our columns. Firstly, I'll rename the section to say column. I will then next select a 200 PSC for our columns. For the beam, we'll use a 180 PSC. To do that, we'll go create, type in beam, add, select, and choose the 180 PSC. Currently, all of our model members are based on the column section we have, so we need to change the beams member to have its beam section. One way to do this is while the beam section is open in this window, we can click on the beam and go assign. Alternatively, with the beam selected, we could have looked at the object tab on the left pane, found the section row and used the drop down here to change it. This object tab also allows us to change a few other settings on the beam, such as material or fixities. If we zoom in on a model, we can visually see the sections we've chosen. The next thing we will do is add our loads. As we defaulted some load combinations at the start, our load cases and our combinations drop down are already populated with what we want. If you need to create your own load cases or combinations, you can click the buttons next to the drop downs and create them from there, in a very similar way to how we've created the other things in our current model. An important thing to know with loads in analysis is that they need to be defined based on their load case and must be separated out into dead, live, wind, etc. when originally defining and adding them. This will hopefully become clear when we go through the process of analysing our frame. So to create some loads, we'll go to the drop down of the loads button and click load definitions. In here we can start creating our loads. First load we'll create is a dead load UDL. So we'll call it UDL1 dead load and click create. If we want the dead load to be 3 kilonewtons per meter, we can add -3 into the Y input, so that the force is downwards. Something to note here is that the load doesn't know if it's a dead load or that it's a UDL or point load yet. It's just a unit force. We decide what kind of load it is when we add it to the model. That's why we've named it UDL1 dead load, so that we can remind ourselves what it is when we add it. Next, we'll add a live load point load. To do that, we'll go create, we'll go point load 1 live load. Go add, and in this case we'll use -4 kilonewtons for a 4 kilonewton down load. Finally, we'll add a horizontal wind load of 4 kilonewtons to the right. So the same process, we'll go point load 2 and go wind load and click add. To now add in the force as a horizontal load, we'll go into the X and put in 4. One thing to remember whenever you're adding any loads is to make sure you tab, click or enter out of the input cell once you've put your load in, like so. Otherwise, if you close it without doing this, the loads will not be recorded and you end up with a point load, in our case, with no load on it. Now that our loads are defined, we can add them to the model. Whenever you add a load to a model, you first need to make sure that you're viewing the correct load case, and also ensure that you're only viewing one load case at a time, as when we add a load, it is added as the load case you are currently viewing. To manage which load cases we are viewing, we can use the cases drop down at the top. Here we can see a tick next to only the dead load case, indicating that we are only viewing the dead load. Next, we will add our dead load to our model. To add our UDL to the model, we first have our member selected, which we already do. Right click, member selection, add member UDL. Do notice that as we discussed before, none of the loads we defined know yet what load case they are or what kind of load beyond being a unit force. It's at this point where we define what kind of load they are. So to add the load in, we will click UDL1 dead load. If we then zoom out, we can see the UDL1 dead load has been added as a UDL on our member 2. As a default, the UDL will go over the entire member from node to node. If we highlight the load on the model, we get a variety of options in the left object pane, such as changing the load start or end position, or changing the load starting or ending load, which can be used to create a triangular loading distribution. There's even an option to change the load case it's applied to if needed. For this example, we'll just keep it as the default UDL though. The next load we'll add is the live load point load. First, we'll need to go back up to the cases, untick the dead load, tick on the live load, and then in the same way we did before with adding the UDL, we'll click the member, right click, member selection. Instead, we'll click add a member point load and select our point load 1 live load. Here we can see point load 1 has been added to our member 2. The load will default to the middle of the member, and if we wanted to move it, we could use the object pane to the left like with the UDL and change its position. Finally, we'll add the wind load point load. And rather than add it to a member, we'll add it to a node. First, we'll turn on the wind and turn live off. Next, we'll click and then right click the node at the top left, node selection, add node load, and go PL2 wind load. With all the defined loads added to the module, we can now look at analysing it. In Analysis Lite, you have access to just linear analysis, which provided you're not working with large deflections or very slender members, it'll generally do the job. Toolkit will warn you if second order might be needed upon analysing a model, but often the actual difference in the two methods can be quite minor. Do note, however, that second order analysis is an analysis standard only feature. To analyse the model, either press the linear button at the top or the F5 key. We then get a window appear with any details of any potential problems with the model analysis. In this case, we get a warning about performing second order. At this point, it's up to the user to decide whether this is necessary, using your engineering judgment. In our case, we're working with small loads and the frame isn't that slender, so it'll likely be okay. We'll get a better idea when we look at the calculated deflections. So in this case, we'll just go OK. To get a better look at the model, we'll go Zoom Extents. As default, we will be showing the moment diagrams for our first load combination, along with its reactions. From here we can use the results drop down at the top to switch between either load cases only or the other combinations we had. There's no restriction on how many are shown at once, so you could have all of them shown at the same time if you really wanted. For the analysis we've done, the ones that we're interested in are probably the last two combinations. The next thing we can use to change the results shown is found in the Viewer tab on the left. At the top we get some model-specific options for showing the nodes, members and restraints, etc. And at the bottom we get the results diagram options. At the moment all we have is ticked is the major bending moment and reactions. If we wanted to see the shear forces as well, we can expand the forces option and click on the shear. Same goes for the axial and the deflections. Another thing you can do with the results on the model is scale them. For clarity, I'll turn everything off but moments. Although the moments on our model look relatively fine as they are, we will scale them anyways. To do this, we want to make sure we've clicked on the model space, hold down the M key for moment, and use the scroll wheel on your mouse. Same can be done for all other result types, but with different hotkeys. For shear you use V, axial you use A, and deflections you use D. Analysis has a lot of shortcuts available if you're interested, and details on this can be found by clicking the shortcuts button on the top right. Deflections also have a few visual options to play around with. To best show this, we'll have a look at our ultimate wing deflection. So we'll turn off our combinations and put our primary wing load case on. Using the scaling feature, we'll scale down the deflections so they're a bit easier to see. Do note that this deflection is yet to have any serviceability ratios applied. Here we can see a horizontal deflection of about 8 mm. To get a better visual idea of what's happening to the frame, we can turn on the 3D option to the left under the deflections dropdown. Here we get an idea of the stress concentrations on the frame and how it's deflecting due to it. You can see that as we have kept the fixity of each end of our beam to be entirely fixed in all 6 degrees of freedom, which is the default, it is causing the shape we see here. If I were to change the beam ends to pinned, which can be done through using the fixity options we discussed before, or by using the end releases feature under the member selection and going to pinned, and also making the bottom restraints of the frame fixed, we would get an entirely different stress distribution, like we can see here on a different model. These options should give you a pretty good range of flexibility with setting up the kind of model you want. Another thing to note with analysis is that it isn't an integrated design package. For designing the capacities of members, you'll need to extract the forces yourself and put them into a member design module depending on the material you are using. This is where the split screen feature we discussed in the Getting Started video would be useful. The final thing we'll look at is printing or exporting this model. The best way to do this is to set up some print views, which are essentially a snapshot of a particular view of the model with certain results, loads or descriptions shown on them, which is set to be printed. The easiest way to set these up is to use the auto-generate function. For this we'll position the camera on the model a bit better, as this is what will be used for the view for all the print views. To use the auto-generate, we'll go to the drop down on the prints option at the top, click auto-generate. This will then reanalyze the model. We'll go OK. This will then bring up a window where we can choose what we want auto-generated as a print view. In this case, I'll just leave the defaults on and click OK. It will then ask us what we want to call the current camera position as. And then the 8 print views will be created. If we then open up the prints icon, you can see all of the prints that were created. Double clicking on them will show you each of the print views set. As we can see here, we've got the geometry of our model we created. If you find a print view that doesn't fit within the model space well, what we can then do is edit one. To update a print view, all we need to do first is have it selected, then edit it as we want. this case I'll just zoom out a little bit. And then we want to click the Update Print View button. As we have changed the way the camera is looking at the model, we will now need to create a new view. And in this case, we'll just use the current view and call it View 2. We'll then check the rest of the models just to make sure they look alright. In this case, we can scale down the moment of it by using the M key and the scroll wheel. Finally, we have the deflections, which looks alright. Once happy, you can export or print as usual, or even use the print or export all option within Analysis under the Prints dropdown. This about covers all the major features of Analysis Lite. Feel free to check out our website and our other videos for more tutorials and help with using this software. If you have any questions, please contact our support team via email or by calling us. Thanks for watching.